The next carbon nucleophile that we're going to look at is cyanide. And cyanide is great for forming a compound called a cyanohydrin. And this is a new reaction. We haven't done this one before. And this reaction, you can use just HCN as your reagent, but it doesn't work as well if you use just HCN. So typically we're going to see cyanide ion, KCN or NaCN, and also HCN together. So you might see, instead of cyanide written, you might see KCN or NaCN. This reaction works great with either aldehydes or ketones. We're looking at it with ketone. And what we're going to do is just start coming up with a mechanism for this reaction. We don't even quite know what the products are yet. So for this reaction, the mechanism, this is just a regular, normal nucleophilic addition reaction. So we're going to take the negative charge of our cyanide nucleophile and we're going to use it to attack the carbonyl carbon and open up the carbon-oxygen double bond just like you would expect. And let's draw the product that we get when we do this. So we have an O- because we've opened up the double bond and we've formed this new bond with the cyanide ion down here. And then all that we have to do is protonate that oxygen, and we're going to use HCN as the acid for protonating the oxygen because we do have that available. So we're going to go like that, and I'm going to redraw this and kind of clean up the bond angles a little bit. So this is the product that we end up making, and this molecule is called a cyanohydrin. So the mechanism is very simple. We've got another example down here with the cyanohydrin, and so this is going to ask us to just predict the products. We don't have to draw the mechanism if we don't want to this time. So we're going to think about what happens in this reaction. We know that the carbon-oxygen double bond opens up to become a single bond. We add the cyanide to what used to be the carbonyl carbon, and we also protonate the oxygen. There we go, and that's our product. Now there's a couple of interesting reactions that we can do with cyanohydrin that I want to talk about a little bit. We're going to get into these reactions in more detail in a couple chapters, but right now I just want to mention them just a tiny bit. So first of all, you can react a cyanohydrin with lithium aluminum hydride and water, and it's going to reduce the cyanide bond. So this is going to add hydrogens all over that carbon-nitrogen triple bond, and it's going to turn it into a CH2NH2. And again, this is a reaction that we'll look at quite a bit more closely in, I think it's chapter 22. So that's one option. Another, and this one shouldn't seem that crazy because we're just, remember that cyanide is, might be helpful if I draw the cyanide functional group out. Cyanide is a carbon-nitrogen triple bond. So when we're using hydride reagent, we're just adding hydrogens to the carbon and adding hydrogens to the nitrogen, the same way that we would do a hydride reagent with a carbon-oxygen double bond. The other thing that we can do with cyanohydrin looks quite a bit more magical. This reaction, we just use acid and a little bit of heat, and it converts the cyano group to a carboxylic acid. So I want to highlight in both of these, I want to highlight the cyanide carbon. It doesn't go anywhere in either one of these reactions. It's just some changing to the functional groups. Both of these reactions we will study more, as I said. These are reactions of cyanohydrins. The reduction reaction with LAH, you can probably kind of imagine how that works, but we are going to look at it. And then the other one with H3O+, that probably seems really, really crazy. You're just going to have to wait a couple chapters to see the mechanism for that reaction, but we are going to cover it.